Okay, here are some calculation on significant figures, right? So first, if it involves multiply and division, we have to find the factors by looking at the fewest significant figures. Okay, for example, this one 0.82727 meter, alright, times by 0.762 meters. So how much? What is the answer? So we found out from calculator is 1.392174174, but then the fewest significant figures here is 3 compared to here is 4. So the answer must come with 3 significant figures. Okay, so addition and subtractions also refer to the fewest decimal places. Just now, division and multiplication refer to the fewest significant figures. Here is the fewest decimal places. Right, so for example, this one, when you add these two numbers, you find out another number, and then you subtract with another number, your answer is here. So if you look at here, this is not your answer. This is calculator display. So what is your answer? Your answer must come with the fewest decimal places. So you look at among these four numbers, which one has the fewest decimal places? Of course, this one. 2 decimal places at the end, right? So we choose that one as our answer. So the answer would be 112.13 with 2 decimal places at the end. Alright. Okay. So there will be uncertainty and error in calculation, especially when we report some values. Alright, so for example, this one, when we have the measurement in BRAP, we have plus minus 10. So it would be that our calculation will be uncertainty at some point. Right, or measuring cylinder. Alright, so we have this one, 26.4 plus minus 0.1 milliliter, and BRAP, so we have 24.40 plus minus 0.01 milliliter. Right, so that shows uncertainty somehow. So how we going to calculate uncertainty? This is the formula by find the percentage error. Percentage error is equal to experimental value minus standard value over the standard value times by 100. That will give the percentage error. Alright, so significant notation is purpose of significant notation, often to express very small or very high number. This is, we just see it before, how we convert the small number into time minus 5 here. Okay, and then addition and subtraction, if it involves this one, if it involves a small number or biggest number, so how we do it? So 4.31 times 10 power of 4 and plus 3.9, 10 power of 3. So how do we do this? Alright, so if we add it up like normal, we're going to see, first thing first, we have to similarize our numbers. Okay, the number here. Okay, make it to 10 power of 4. So we're going to see the answer in 10 power of 4. Right, so multiply and division. So multiply and 1 and 2, exponent and 1 and 2 first. Okay, so first thing first, what we should do, we should split them. Okay, let's say 4.0 times by 7.0, then only times the exponent here. Okay, exponent here, exponent for multiply, it means plus. Okay, minus 5 plus minus 3, so that will give the answer of this. Alright, and then we can simplify our answer into 2.8 10 minus 1, because this is, there's no decimal places here, so it doesn't mean, it's not good to see in that kind of number. So this number is the best. Okay, right, for division, we divide the numbers first and then we subtract the exponent. Okay, number, you put the number all together, 8.5, divide by 5 and then subtract the exponent. So you got 1.7 10 minus 5. Okay, that's the best number. We can't simplify anymore. Okay, so in terms of dimension analysis method of solving problem, we have to determine which unit conversion factors are needed, and then we carry unit through calculation. If a unit cancel, accept the desired units, then the problem was solved. Alright, so for example, given quantity times conversion factor is equal to desired quantity. So if you want to do this kind of thing also can, given unit divide times by desired over the given units, that will give you desired unit. This is the same thing. Alright. Okay, so look at this one. This is metric factors and also common factors. That's okay. This is in terms of conversion, how you convert the factor. Right, so for example, from centimeter into an inch. Okay, if you want to divide this one into the centimeter, inch over centimeter, or centimeter over inch, that's this kind of conversion. Okay, how many centimeters in 26 inch? So given quantity is 26 inch times by conversion factor 2.54 centimeter over inch. So inch and inch will be cancelled out. So your answer would be in centimeter. Another example, for example, 5 foot 10 inch man in centimeter and meter. Answer in 3 significant figures. Alright, convert data into feet. Okay, 1 feet is equal to 12 inch. So feet over feet will be cancelled out. Okay, 5 times 12 inch is equal to 60 inch. Okay, right. Because it has 5 foot 10 inch, so the answer is 60 inch plus 10 inch. That will give the answer, final answer 60 inch. Okay, so now try to do this exercise. Convert data into centimeter and also into meter. Okay, the answer is given. Just look at on it. Alright. So this is another problem. Okay, for example, in liquid nitrogen obtained from liquefied air and used to prepare frozen foods. Okay, so the density of the liquid at its boiling point is 0.808. Convert into kilogram per meter. Okay, try to solve that one. Okay, here, okay, it shows you one thing. Okay, so we have conversion of kilogram. 1 kilogram is equal to 1000 gram, and 1 centimeter cube is equal to 1 minus 6 meter cubic. Okay, so if you want to convert into kilogram per meter cubic, gram times by 1 kilo over gram. Okay, gram will be cancelled out, and then you have kg, because this is 1 kilogram is equal to 1000 grams, so that's 6 kg. And then don't forget, here you have gram per centimeter cube, so 1 centimeter cube is times by 1 centimeter cube over 1 times by minus 6 meter squared. So that this one and this one will be cancelled out. The rest will be kilogram per meter cubic. Right, so you calculate, the answer will be 808.